Thank you. Hello, everyone. Thanks for coming. My name is Dimiter Naydenov, and this is my first ever EuroPython talk. So thank you. I'm quite passionate about pandas, and I hope by the end of my talk, you might want to try it as well. So let me first tell you a few things about myself. So I have been a software developer for over 20 years now. I started back in the day with BASIC and Pascal, went through C, C++, C#, even PHP for 3 years. And then I discovered Python through Django. And Python became my favorite language by far. Since then, I've used it for pretty much everything. Server-side software, scripting, web apps, mobile apps, and all sorts of other things. So I was working for Canonical for 4 years, and I was working on a port from Python to Go of a cloud deployment suite. And after that, I decided it's time to get on my own. So I went full-time into freelancing with Python again, happily, and founded my small own company, Develated. So, what about pandas? So, seriously, how many of you have used pandas before? All right, great. So, have you used it for anything else than scientific and statistical software? Okay. So, just a quick introduction for those of you who don't know about it. So, Pandas is an open source Python library. It was created in 2008 by Wes McKinney. It has high performance and easy to use data structures, and a great API for data analysis built on the solid foundation of NumPy. And it's also very well documented, too well, in a way. So I first heard about pandas in EuroPython 2012, I think. And since then, I kept hearing about it from all sorts of people all the time. And I decided to look into it and see actually what it's all about. I'm not from a scientific or financial background, so that was my first experience with it. Basically, I liked about it that it's easy to install. It has very few requirements, especially on Linux. It's trivial, but also on Windows and Mac OS. It's as fast as NumPy, yet a lot more flexible. And I personally don't really like NumPy that much because I found it somewhat counterintuitive and awkward to use. Pandas also reads and writes formats in pretty much any format you might have to deal with, especially CSV, Excel, and HDF5, to name just a few, which was an obvious advantage for me. And also, since I'm quite a visual thinker, I like how easy it is to plot stuff with pandas, with Matplotlib. So I did try it, but I found some quirks and pain points which kind of put me off. And I want to share a few of them with you. So it has a good documentation, but at the time there were not a lot of tutorials and hands-on guides. It was a bit intimidating to read all of that documentation and know where to start from. There are also confusingly many ways to do the same thing, kind of unPythonic in a way, at least then. Also, there are lots of indexing, like every sort of indexing operation, which was, it's also its power, but I didn't understood it then, and it was kind of, seemed to me pointless, especially the multi-index. And it has same defaults for most things. It can handle lots of types of data intelligently, however, not as fast as you might like. So You might want to actually be specific when you want to deal with specific types of data, like date time or floats or integers, and do some conversions in between. So let me tell you about a project of mine, which I kind of found unexpectedly how good fit Panda is for some of the tasks I have to deal with. So the project is an SVG mail labels generator, which means send personalized mail in senders labeled on the envelope in sender's handwriting. And this is done by following a few requirements. So one of them is acquire a sample of the user's handwriting on a tablet, and it's acquired in a vectorized SVG format. Then extract individual letter or symbol SVG files, small ones, from each of those sample pages per user. Then out of those, compose arbitrary word SVG files and make them look as if they're written by hand. And finally, generate mail labels from those words, sticking them together into multi-line, multi-word labels. So first, the acquisition of handwriting samples is done on a tablet, stills, or a pen. Every user gives one or more of those samples, and they're saved as SVG files. And this is an example of one of those. So basically, it's a standardized text that every user decides what to write, and it writes that sample on several different pages. So to have basis for comparison, basically. And each of those things are basically SVG. The pen strokes are recorded individually in the SVG file as vectorized curves. And this is, for example, how it looks like one of the outputs of that process, which is a mailing label done for one of the users. So, sorry, the zooming is kind of weird. So this is the generalized process. It's a multi-stage pipeline of sorts. So it first starts with the parsing of the SVG sample page. Then enter Pandas. Pandas is used to read those and present them in a tabular fashion in a data frame, so they can be easily handled. Then there is a letter extraction process, which heavily uses Pandas to extract individual strokes and combine them as they were on the page, so that you can come from single individual strokes to actual letters and then reuse those. Then there is a classification step, which is done manually and basically labels each of those extracted letters as A, B, C, $, and so on. After we have this, there is the word building stage, where we select letter variants for a specific word, stick them together, apply some alignment, and so on. And finally, there is the labeling stage, which is producing labels out of those words and aligning them ready for printing. So let's look into the parsing first. The problem is how to extract meaningful information from that XML SVG in Python. And what I found is this excellent SVG path tools library, which has a lot to offer. So it has a path-based class and a few subclasses thereof, like line, cubic Bezier, quadratic Bezier, and a few other top-level utilities. Each of those classes have rich APIs for path intersection, calculating bounding boxes, transformation, scaling, and all sorts of other things. You can cut paths, you can translate them, and so on. And also it allows you to easily read and write lists of SVG paths into or from SVG files, and also apply some like scaling and other things. So, and it just takes a single line. So this is basically an example of how easy it is to get those paths from a file. And this SVG2 paths takes a file name and a bunch of other optional arguments, deciding how to convert and what to convert. So it converts everything to those three primitives: line, cubic, and quadratic Bezier. It handles arcs, circles, and all other things. You know, it converts them all into those. And returns a list of path instances and a list of dictionaries which contain the extra XML attributes of each of the paths. So once we have these, this is the easiest and simplest way I found. So we use Pandas dataframe.fromRecords, the class method, which takes an iterable, or in this case, a generator of dictionary-like objects with the same structure. And in this case, what I cared about is the actual index of that path instance within the file, and as well its bounding box. So the minimum and maximum horizontal and vertical coordinates that fully encompass that stroke. And we get a structure that looks kind of like this. Then, onto the letter extraction. So the problem is quite computationally intensive if you address it from a naive, algorithm. So you need to compare each stroke with all nearby strokes, which might have something to do with it, and merge them together as letters. And what I found is that using a data frame, simple iteration and filtering, albeit over multiple passes, you can do that easily and in quite quickly as well. So the multiple passes are done by basically taking the data frame and returning it modified, along with two sets of indices, one for merged paths and one for yet unmerged paths, which you can see here. Using the data frame, you can easily extract those, and then each of the steps, which I'm going to show one of them, which is this, merging the fully overlapping paths. Basically, all of them look like this. So we iterate over the data frame, taking each path in sequence, and then we filter the data frame. For example, in this case, all the paths that fully overlap their bounding box, fully overlap with this current path. We take this as candidates, like a subset of the data frame. Then we run a fairly complicated merge procedure, which I won't show because it's like a page and a half. But basically what it does, it updates the data frame so that when you merge two paths, they have the same bounding box, so updates the xmin, xmax, and so on of both to match the combined bounding box of both, and also updates those merged and unmerged sets, and returns the data frame. And after each of those steps, we run update data frame step, which calculates additional properties for each of the paths. And since Pandas allows this quite easily, you can chain assignments like this, like, for example, calculating the width or the height of the bounding box, the half width, half height, which is used in some of the merge steps. Also the area with multiplied by height, and the aspect with divided by height. And finally, we need to sort the values so that they come in kind of natural writing order, top to bottom, left to right. So then once we have this, we have a bunch of smaller files, letter files, which we then need to classify. And this is a deliberately manual process as per the client requirements. There is an external tool they used already for this sort of thing. There is no Pandas, unfortunately. So it loads the merged and unclassified letter SVGs, shows them one by one to a human, allows the human to align them, in the box of the letter or the background, and also allows them to label them, like this is a $sign, this is a capital A, this is a lowercase l, and so on. Once we have this, we have labeled SVG letter files, letter variants, and then we come down to the word building. So this is an example of an intermediate output of the algorithm, which is a debug version showing the letters, their bounding boxes in green, and the running baseline of the word, which is the line along which all the letters are aligned. So it looks like they're written on the same line. So it takes a single word as an input, for example, testing. It does a selection process for each letter, either sequentially or randomly with a seed. It picks a labeled variant for that letter. Then does horizontal composition, merging selected variants with variable kerning, which is a typographical term for the spacing between the letters. And then there is a vertical alignment step, which, according to the running baseline, aligns certain letters, like, for example, G, Y, and others, to they are either below the baseline or above the baseline as needed. And outputs a single SVG file for that word in the same size. So the labeling, just to remind you how it looks, basically it takes as an input an Excel file with mail addresses. No surprise here. Pandas works great with this. So the structure is 1 row per label, 1 column per line. As simple as parsing using Pandas read Excel. And the generation stage builds words with variable spacing, 1 for each column. And the alignment is done with so-called variable leading. So the leading is the vertical equivalent of kerning, so the spacing between the lines. And that's it, basically. So I think I should tell you what I learned from this process, basically. So Pandas is great for any sort of table-based data processing. That was kind of an unexpected discovery for me. So it might be intimidating at first if you haven't used it. There's a lot to read, but if you learn just a few things and start from there, like filtering and iteration, you can go a long way. Also, take time to understand the indexing and the power of multi-index, because that gives you the power to deal with multidimensional data in a very comprehensible way. Then also, of course, anytime you need to deal with CSV or Excel, which is quite a pain otherwise, with Pandas it's trivial and fast. Doesn't have to be, financial data or anything. And also the documentation is great. There is a lot to read, so it could be a bit confusing at first, but I would suggest start with 10 minutes to Pandas, which is one of the main sections of the documentation. There are also a lot of tutorials now, a lot of cookbooks, hands-on guides, and it grew a lot. There were actually recently a documentation sprint for Pandas, which expanded that even further. So with that, I have just one more thing to say. Please consider buying Wes McKinney's book, Python for Data Analysis, because it's great and it will help you a lot with your journey into Pandas. And I'll be happy to take any questions. Thank you.
Thanks very much. Are there any questions? We've got lots of time.
Sorry, I may ask a silly question. I know you said all we need is Panda. Have you met any, in your practical user case, in your practical life work, have you met some limitation of pandas?
Oh yeah. Well, there are things, quirks that you tend to learn to live with, but you tend to overcome as well. Like, for example, dealing with any sort of numerical data that can have gaps in it, or possibly strings or anything. They turn up as nans instead of something else. So if you expect to get integers, you might get floats instead. But yeah, that's...
Yeah, the type converter is one thing. Another use case I would like to raise to our community to pay attention to is from my work, a use case. The data input we got is a nested JSON file. It's a JSON nested JSON string. So the pandas, use pandas read JSON can only process one level.
Yeah.
So that makes it very...
I haven't used it personally for JSON. I think Postgres is better for that, if you can afford it. I mean, if you can have it at hand.
My solution is I have to write my personal library to process this one into a data frame, but that's quite static. So I was always thinking if the pandas can absorb this feature, basically he analyzes the JSON files. Because the output is always, even though it's nested JSON, the output will be pandas, data frame. So I was thinking if the pandas can absorb the feature, basically, firstly, step one, analysis the JSON file to identify these keywords. Step two, just crunch and get the data frame out. It will be an improvement for pandas, but pandas is splendid. I agree.
Sorry.
My question is the limitation of the pandas.
Yeah. So I'm sure you can go a long way using pandas for some part of that process. Reading the JSON, the nested JSON. And for sure, if you can convert it to something more tabular, you'll get a lot more out of pandas.
Cool. Are there any other questions? No one.
So I hope you try it.
All right. Thanks.
Thank you.